the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is for linear algebra students who are currently going through a discussion on the characteristic equation surrounding eigenvectors and eigenvalues, and this short video is to cover some very useful theorems as you go through to try to find eigenvalues using the characteristic equation. As I state in this note, the following list contains old theorems, but it's presented here because these theorems can be helpful when working with the characteristic equation. And here is that list. Now, not everything in this list is going to be of ultimate importance. However, there are a few here that are going to be incredibly important. For example, A is invertible if and only if the determinant is non-zero. The determinant of a product is the product of determinants. If you have a triangular matrix, then the determinant is the product of the entries on the main diagonal of that matrix. E, F, and G have something to do with row operations on a matrix and the determinant of the resulting matrix as opposed to the determinant of the original matrix. That can be very, very useful, and we'll see that in an example in this video actually. And actually H as well belongs to that group, E, F, and G, just because they all pertain to row operations on a matrix. Now, I don't mean to leave C out of the loop here. It is actually important. However, I don't use it that often when just dealing with regular old characteristic equations, but it does become useful pretty soon. So if this matrix looks familiar to you, it's because we actually dealt with it in the last video. And remember, we were asked to find the eigenvalues of this matrix, and we just went ahead and expanded A minus lambda I about the second row. However, I do want to showcase an alternative method using the properties of determinants that we just have shown on the previous page. Now, here is the determinant of A minus lambda I. What we're going to do is actually swap rows 1 and 3, and when you do that, the determinant pops out a negative. Now, you may be wondering, why in the world would I go ahead and swap rows? Well, this way I can use row 1 to kill off this entry in row 3. So I could take the opposite of 6 minus lambda, multiply that against row 1, add that to row 3 to become the new row 3. It is actually very useful to do that. Now, what you see right here is just me having multiplied this first row by a negative quantity 6 minus lambda and adding that to the third row. This is what we get here. Also, I'm going to go ahead and swap again rows 2 and 3. Again, you might be wondering, why in the world would he do that? Well, it's because I'm going to get this in triangular form, so I can just read off the determinant of this matrix. Negative times negative is a positive. Let's go ahead and take a negative 1/3 times the negative 2 minus lambda times row 2 and add that to row 3 to become the new row 3. Basically, I'm just turning that 3 into a negative 1 and then multiplying it by negative 2 minus lambda so that when I add it down to the element below or the entry below, it becomes 0. And remember, this row operation, whenever you do a row replacement, it does not change the determinant of your matrix. Now, when you get down to this point right here, remember we have a property that says if you have a triangular matrix, the determinant is the product of the main diagonal. So the determinant of this matrix would be 1 times 3 times this mess right here. Well, we know that the 3 and the 1/3 will cancel. The negative I'm just going to distribute into this so that we could see this determinant will be the following. And if you simplify this down, you will get actually what we had in the previous video. And I almost forgot that plus sign right there. That was very critical. So when you get down to this, you find out that your eigenvalues are lambda equals -2, multiplicity 2, and lambda equals 5. Now, I gotta tell you, and you would probably agree with this, that this is a terrible way of doing this problem. It's just much easier to do the straight determinant rather than doing row operations. But this illustrates the fact that you can always do row operations if you want. You just have to take into account the modifications to the determinant as you do those row operations. And trust me, it can be very advantageous to use row operations before computing your determinant. In fact, we could have started this problem, swapped rows, done what we did here, which is add negative quantity 6 minus lambda times row 1 to row 3 to become the new row 3. Get down to here and just go ahead and say, well, this is the opposite of the determinant of this mess, but what I'll go ahead and do is expand about the first column now. And if you take a look at that, that means that you really only have the product of this minus 0. So that's a really, really nice way to work a problem. Now, I want to repeat, it's actually not advantageous in this example, but in many other examples, it can be advantageous. So the purpose of this video was not really to introduce anything new. It was just to remind you of the options you have when working with determinants. Keep that in mind, because you can miss some great opportunities if you forget these theorems and these properties of determinants. All right, that's all I really had for this video. So I hope to see you in the next video, and I hope you have a great day. Be an awesome human being.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Listen close, don't talk too much that isn't cold. Sure, you may really hurt inside. It doesn't justify you to speak too loud and cry.